Welcome to Math 104, where we're talking about quadratic regressions, either with ATI 83 or 84. So I would highlight this quadratic regression part. So in case you are flipping back to your notes, you know exactly which one we are talking about here today. So same things as the last time. Make sure you're just clearing out all your lists. Honestly, I would just do a full reset every time. You don't have to, of course, especially if you need your diagnostic on, which is to get R and R squared. Keep in mind, if you are not seeing R or R squared, you need to hit the following buttons, and I'm going to just put it down here. If not seeing R and or R squared. Sometimes you might see an R squared, which we'll talk about here in a second. But if neither of these are coming up, then hit second 0, and then go down until you see diagnostic. On. There's going to be 2 on and off. You're going to click on, just click it in a couple times. Now, if you see R squared and not R, then you're going to take the square root of R squared to get R. Nice and simple. Now, there's only one regression we'll be working with in the future that will not have an R or an R squared that is given by your calculator. So in that case, what we're going to have to do is come up with reasons why we believe that model to be a good fit. But alas, that is not the video we're working on today. So making sure that everything is reset, making it look nice, we're going to go ahead and read this new problem. It says the data shows the percent of people in the world who are internet users from 2014 and projected to 2025. Find a quadratic function that models this data. So they've already told us that we're going to be using a quadratic function, but we always want to make sure that it does fit a quadratic model using some of our discoveries like R and a visual perspective. And then we'll go ahead and also see if your average error works for this quadratic model as well. So we're going to be looking for a quadratic function. It does say 3 significant figures. So we will work on that as well. Then it says, find the number of years it takes for the model to reach 57% of internet users. And then part C says, use the model to predict the percent of internet users for the year 2023. So let's go ahead, and we're going to be entering in the data values. Keep in mind, if you see a sentence that looks something like this, X is the number of years after 2010. That means when we are looking at the year 2014, are we going to be really typing in 2014? No, instead it's going to be the year 4, quote unquote. So what we're doing is we are subtracting 2014 from 2010 to get those values. So pause the video, see if you can change all of these data values into the new proper notation that we're using so that the years make a little bit more sense in the context of our problem. Okay, so your new values should be 4, 5, 6, 7, 8, 9, 10, and be careful, it is not number 11. It does look very, very promising to just continue down. But when we go over here, 2025 minus 2010 is not 11. Instead, it is 15. So be super careful. Not all data will be nice and neat. So once we have recorded these into your list, keep in mind how we get to our list. I will make sure we highlight these. We're going to hit Stat Edit. And then the very first edit, we will be putting in your data. Now we have list 1 to be your X values and list 2 are our Y values. So once they are inputted into list 1 for your X and list 2 for your Ys, always double check and see what does a graph look like. Now, in order for us to make sure that your graph pops up, we want to make sure that two things are done properly. Number one, be sure that your scatter plot is on. To do that, we want to make sure we're going to be entering in second y equals and switch that plot to on. Okay, so if it's on and you're still not seeing it, then number two, be sure the window is accurate. So let's take a look at our data in order to form the most reasonable window that we have. So these being your x values here, and these being your y values, I'm sure we can come up with something to sandwich these values in. So it does tell us that we're working in the year 2010. So we can, if we wanted to, start at the year 0 and work our way up to past 15. But keep in mind, we read in here that we're going up until 2025, which is 15. So we don't want to stop at 15. We want to get a little bit further so that we actually can see that data value. So make sure that we're sandwiching those values. So we can perhaps start at 0 and then branch up. If our values stop at 15, maybe we go a little further, maybe 20, 25. A scale, you could go up by 1, you could go up by 2, it doesn't matter. I would suggest 1 since all of our values are going up by 1, so we can see them looking really well. But again, we can always change it. Now let's take a look at your y values. So your smallest y value is, in this case, 41.1. So if you wanted to, you can certainly start at 0. You can start at something a little bit closer to the 40s because they don't go up all that quickly or all that high because we're stopping at the highest one here happens to be 60. So maybe we start our values at 30. And we go up to, maybe I go up to 75 in your y values or your y scale. Your y scale is something maybe a little bit bigger. Maybe we go up by 5s or by 3s. Okay. Again, this is how you are kind of trying to build it. You don't have to be exactly like mine. This is just a presentation on how you can create a good model based on the data that's given. So let's go ahead and do those. Hopefully I can remember our window. So just to get to your plots, notice that they're all in here. I want to make sure that everything is turned on. There's nothing in my y equals. And let's go to window. Window is not good. We said we're going to change this to 0 and maybe 20, going up by 1s. Perhaps this was 30, 75, and going up by maybe 3s. Let's give that a look. All right, so not bad. Please ignore the intersection, plot, and x equals. I can't seem to get those to go away. But as you're noticing, all of the data is found here. And from here, if we were doing a project, I would say, hey, based on your best guess, what models would work? They've already told us we would like a quadratic model because there is a slight curve to it. It's not exactly linear, but one is up for interpretation. So let's go ahead and hit second mode to kind of go back now that we have seen our graph and everything is plotted. They're telling us we are going to go into a quadratic. In order to do that, we're going to hit stat calc. And instead of last time we hit lin reg ax plus b, we're going to hit the next one called quad reg. That is going to be number 5 on these calculators. So when you go ahead and hit it, keep in mind, it does ask us a series of questions. Don't forget to store your equation. In order to store your equation, down here, for those that see it, when it pops up, the store reg EQ, you're going to be hitting these following buttons. If you're working with an older TI-84 or an 83, it might not have all of this, but you're still going to be hitting these buttons just at the same point that we are. So let's go ahead and do that. So we're going to go to Stat, Calc, and down to Quad Reg. Again, it's just making sure that we have list 1, your X values, list 2 is your Y values. Sometimes as we're doing your average error, this first one might get mixed up, so make sure it's back to list 1. Now this is where we can come to store your equation, so you don't have to type it out because some of these are going to get long and nasty and terrible. So we're going to go ahead and hit vars, y vars, function y1. So now whatever regression comes out, it's going to be storing it in y1. So let's go ahead and hit enter. And it pops up with this whole thing. Again, these aren't meant to look very nice. What we will be doing here in a moment is rounding out to 3 significant figures. I think it said 3. Yeah, 3 significant figures. And notice that it does not give us R, but it does have R squared. This is one of the instances where we might not see an R right off the bat, but we said, hey, that's no problem. It's really just one extra step. So see if we can pause the video and put this into 3 significant figures. If you want later at the end, we'll just do 3 decimal places to show you the difference. I think I did the opposite in the last video. So this is just a little few more tidbits to give. So let's go ahead and pause. So your quadratic reg, normally we have this set up ax squared plus bx plus c. So that's what we're going to be seeing here. So when we go to write our expression, when we are doing your 3 significant figures, we're going to write out as many as we can. So this is me just recording. Keep in mind, do these first 2 leading zeros, do they count for us? No. So these don't count when I'm going to be counting out loud as how many I want to write. So starting here, we now have a 9, which does count. So I'm going to, in knowing that I'm going to do 3 significant figures, I want to get 1 extra one at the end. So really, I'm going to write 4 more numbers. 2, 1, 0. Now I want to end on this 0 to see if I round my 1 up or if I keep it. Now, because I end on a 0, I can then round, or not round my 1, but keep my 1. So now I have my 3 significant figures, 1, 2, 3. And there you have it. So let's try it again with B. So we have 3, which counts. So now I'm going to be writing out 4 more numbers, or sorry, yeah, 3 more. So 5, 2, 7. So now we have our first 3 that count, 1, 2, 3. Now the 7 is going to tell us if we increase or keep 2, which in our case, we are going to increase 2. So we should have 3.53. Let's do it again, 28.755. So 28.75. So we have our first 3, 1, 2, 3. Looking to the 5, will tell us if we raise our 7, which we do. So these should be all of our numbers listed out. And now we're going to write our equation. So we should say y equals 0.0921 x squared. That is coming directly from this part up here. So maybe I just do this. So this number is right here. There we go. Plus 3.53 x, that's going to be our next value here. plus 28.8 is C for our last one. There you go. So that should be our equation. So that would go here as well. We can rewrite that if I want, or if you use an iPad, kind of like mine, you can kind of just copy and paste, and it comes out rather nicely. You can also use the app tool for your your significant figures. I think it also does a few more, so definitely check that out. Just type in your number and it'll spit out your significant figures. Now for part B, it says find the number of years it takes to get to 57%. Now these percentages are all right here as well. So this number is really 41.1%. They have not moved the decimal place over or anything like that. So we in turn do not have to do anything with that 57. Instead, and again, if you haven't paused the video, I would suggest pausing it right here to try out B. But we have your equation is in y1 is our equation. So that means y2, we have this 57 as a y value, so that can go into y2. What are we going to see? Well, we're going to see some sort of intersection, so that allows us to find your x values. So let's go ahead and do that. And we'll circle about your r squared in a moment. We'll just answer these quickly. So we said there's your equation. Oh, and ours is negative, and I did not get a chance to record that. My apologies. I'm going to go ahead and do that here. I must have missed it when I was recording it. Okay. All right, so we have 57. Let's go ahead and hit graph. Do we see an intersection? We definitely see one intersection, but what do you notice on your graph going more to the right? Because if this is a curve, if we were to maybe expand our window, quadratics, as we know, can either like be a U shape or an N. Ours is most likely more of a little N, an upside down U, perhaps. So we might have another intersection. Now we'll only be able to see that if we expand out to the right, which is our X max. So let's go ahead and expand just a little bit. And now you can see that curve for sure. That's why they liked that quadratic model. So let's go ahead and hit second trace. When in doubt, hit second trace. That's our Hail Mary. Go down to intersect. Watch this quick video.
Nationwide helps.
There we go. So left bound, because there's two, you're going to have to do this a few times. Get to the left of one of them, and then get to the right of another. There you go. You have an intersection at 11.4. And let's try that again. Second trace, one more time, intersect. Left bound, let's do it a little bit closer. Over here, to the left of that one, and then again to the right. And then we have 26.9. We'll round that last one. So you said 11.4 and 26.9. So let's round these because we're going to have, because these are years, you're starting at your 11th year and then you're increasing. You've started on the 11th and you're well into it. So now you're working on your 12th year. Same thing, you've worked through your 26th year and then you're on to the next year. So now these aren't just particularly your year 12 and year 27. That doesn't make sense. Instead, what we did from list one earlier is we said, hey, your X values, they start at the year 2010. So we're going to have to add these values to 2010. 23 minus 2010 is 13. There we go. So we're looking at when X is 13. So let's go ahead and hit second trace, and we have our value, meaning your X value. So anytime you have an X value, we can go ahead and type it in, and it will spit out our Y value. So your Y value when X is 13 at the very bottom in blue says 59.04. So we are at about 59%. So the internet users in the year 2023 is about 59% or 59.04%, depending on how the rounding takes place. Now let's continue this portion on into the average error. So average error, we're going to go back to doing a lot more on your calculators. So let's go ahead and go to list 3. List 3, we said, is your predicted Y values. This will not work if you do not have your Y equation or your equation stored in Y1. Now we're going to go ahead and hit the following buttons. Once we are up in list 3, we're going to hit vars, Y vars, function, and exactly as you see it here, we're going to be entering it in. So let's go ahead and quit out of there. Stat, edit, go up to list 3, now in pink. We're going to hit vars, Y vars, function, Y1, parentheses, and we're going to multiply your equation by our X values found in list 1. And notice how similar list 2 and list 3 are. That's a good thing. They're not going to be the exact same, but as close as we can get it means it's really promising as far as a fit goes. Then we're going to continue over into list 4. We'll go back and check. And if you wanted, you can write down what you have in list 3. You don't have to. We're going to move over into list 4, where we're really going to be subtracting out your predicted values from your equation minus those actual values found on your data. To do so, we're going to be entering in the following. So we're going to hit second 3 minus second 2. And again, notice how small some of these numbers are. That is really good because when we go over back to your graph, notice, and I'm going to get rid of that one in red. Notice how close some of these values are to, not your values, some of your data values are into your curve. That's a really good thing. The closer they are running through the center of your graph, the better the fit. So right here, if I pause the video and say, hey, what do you predict to be the average error? Is it going to be something that's really big or something that's really small? Right? Well, they're all touching our graph, right? All of our data found on your graph are on the quadratic. They're not quite through the center, but they're actually really close. This second one looks like it's just about dead center, right? Some of these other ones are pretty close, like this one. So we should see a very small error. This should be a pretty close fit. So when we go back, again, we said don't use list 5. Instead, we're going to go ahead and hit stat calc. And that first one variable statistic. Make sure we go back and make sure that we're working in list 4. So I'm just going to go back over here. We're going to go to this first one where it says list 1. We're going to go ahead and change it into list 4 by hitting second 4 and then go ahead and hit enter. Now, of all of these things, we said really we only need one of them. We really need that one. So we're looking at the sigma x to be 0.16775. So about 0.17. And if you're confused as to which one we're choosing, we're going to be looking at the one that has sigma x, the lowercase sigma. This is your average error. So the smaller this value is, the better it is. Now let's go ahead and talk about some verifications on why this might be a good model. What are we looking for? So let's prepare for the project. Things that I want to see or want you to discuss are the visual aspect. How did the model, your regression, your line, your curve, how did the model compare or fit well to the data? Fit to the data. Lots of description here, right? Based on how it fit, can you make an interpretation, right? Interpret. Can you predict what you might be seeing in the future as far as your correlation coefficient or your average error? Discuss your correlation coefficient, which is your R, right? We'll go back and discuss R in a second. And then we can say discuss the average error. Does it fit with what we had talked about before as far as a visual aspect, right? Were you correct in interpreting your finding? So all of these things are what we need to determine, is this model a good fit, a bad fit, things like that. So now let's take a look at your correlation coefficient, R. So R, we go back a step. They didn't give our R, instead they gave us R squared. We're still going to be rounding out to 4 decimal places, so we're looking at 0.9992. So we're going to take that number, and because it's a squared number, we're going to undo that square by square rooting it. So let's take the square root of 0.9992, and there we get 0.9996. Again, rounding. So if we're given R squared, we're going to square root it. So R is now 0.9996. Is this a good representation of our model? We said our model, right, was really close to being perfect. It wasn't exact, but it's a very good fit. We want this number to be as close as possible to either 1 or -1, which when we round to 4 decimal places looks really promising. So that does help us with our findings. It goes along with our average error, which is very small. We said visual aspect, again, almost perfect fit. It looked really good visually. So this is also a good representation of the model being paired with the data. Now I'm just going to discuss quickly 3 decimal places for your equation, which I'll go back. If we're rounding this to 3 decimal places, we do not need to worry so much about our zeros. Instead, just as we do with 3 decimal places, we're just going to count out 3 values after the period or the decimal place, 0, 9, 2, and that would be it. You could look to your next number to then increase or decrease that value. Let's do it again, 3.527, and I did not get a chance to record, let's see, 4 is my next one. So do we keep the 7 or do we raise it up? We're going to keep the 7. And if I get lucky, maybe I have recorded the last one. So your last one is 28.7551. Again, that 5 at the very end, we will end up keeping because our very next number is a 1. So this is what it would look like if we had 3 decimal places, very different from 3 significant figures.